Welcome everyone to the third webinar regarding Cyber Essentials. It's run by the Black Country Chamber of Commerce Technology Special Interest Group, which we shorten to the SIG, because it's much easier to say. And today we're going to be talking about the importance of secure configuration and firewall, and all of these presentations and webinars are linked back to Cyber Essentials, because a lot of the things that we're discussing are requirements of Cyber Essentials. So I'll move on to the next slide. So a bit about the speakers for today. So there's me, Matt Yarrington. I'm the owner of Blisstech Solutions. So I've worked in IT since leaving college back in the early 90s, so over 30 years. And 15 years of that was spent as a cybersecurity specialist consultant, working with some of the largest companies in the world. I've since gone back to just regular IT after starting Blisstech Solutions, but I've got quite a lot of experience in the cybersecurity arena. And then we've got Zishan. So do you want to introduce yourself, Zishan?
Hi everyone, I'm Zishan Parvez. I'm Professor of Cybersecurity and I'm also the Director of Cyber Resilience and Artificial Intelligence Research Center at University of Wolverhampton. And we are basically helping businesses and organizations and communities to adopt cyber resilience. So the transition from cybersecurity to cyber resilience, and supporting them to build AI capabilities. And we have a track record of supporting businesses in a range of different areas in cybersecurity, digital power, digital transformation, and AI. Yeah, Matt. Yeah.
Okay, thank you. Okay, so the meeting's scheduled for an hour, but it's probably going to be shorter than that. So we sort of around 45 minutes for the presentation, and that will leave time for any questions at the end. And the agenda for today, as I mentioned, so secure configuration. So we'll explain what it is, the best practices, why it's important, and then around firewall. So you're probably familiar with the concept of the term firewall, but we'll describe what it is, why they're important, the different types of firewalls, and on both of these topics, we'll then link it back to Cyber Essentials and what Cyber Essentials says about these specific things, because there's a lot you can do within cybersecurity, like you can't do as well, but there's certain things that is expected of you when it comes to Cyber Essentials. So we can try and demystify that a little. So first of all, we're going to get on and talk about secure configuration. So what do we mean by secure configuration? So essentially, as the name suggests, it's the process of configuring things so that they're secure. So the reason this is important is many systems, or in fact most systems, aren't secure out of the box. So when you first set something up, if you don't change any settings to secure the configuration on that device, then it can be vulnerable. Examples of this are on a Windows system. So when you first set up a Windows system, the first user that's used to log into Windows will default become an administrator, unless you have configured things so it doesn't happen in that way. So there are lots of people out there running Windows that have admin rights, and we'll come on to why that's not a great idea shortly. And then also a lot of, for example, firewalls, networking equipment, cameras, things like that, they have a default password, and if you don't change the default, then that's a known password out there. Then it's the happy hunting ground for hackers when things are left at their default configuration. So the best practices are to implement secure configuration for each device that's used and system that's used, to make sure that you're establishing robust security. So now we'll talk about some of the best practices. So one of the things you can do to secure configuration on devices is to remove unused software. So if you think of a regular system a bit like a sponge or Swiss cheese full of holes, and each piece of software is like a hole within that sponge or within that cheese. And the more software you have installed, the more vulnerabilities that there are to exploit. So in the previous webinar, we discussed around patching vulnerabilities, installing software updates to remove vulnerabilities. every piece of software has vulnerabilities, and the more software that you have installed, the more vulnerabilities there are to exploit. Again, another example, when you buy a computer, depending on where you buy it from, if you buy like a consumer grade Windows device, it's full of what we call bloatware. So it's got games installed on it. It's got all of these different things that you probably will never use. And each one of those pieces of software is a potential avenue in if it contains a vulnerability. So removing the applications that you don't need minimizes that risk of exploitation. You know, the less stuff you have on there, the less likely it is to be vulnerable to some kind of attack. So when you receive a new device, what you should do is just go through it and uninstall any applications that you don't use, or better still, wipe it and start from scratch. And we'll talk about that in a moment. And the same goes not just for Windows, but Mac devices, any type of operating system. So another thing to do to secure the configuration of the devices is to remove any unnecessary accounts. Again, out of the box, a lot of devices come with default accounts configured. They may have a default administrator account and things like that. So disabling those accounts or deleting the accounts that you don't require helps to reduce that attack surface area. And also changing default passwords, as I mentioned, so for example, if you order internet through BT, as an example, on the back of that router, there will be a default administrator password that anybody can pick up, have a look at, and log on to your router as an admin. And then once you've got admin rights, once you have admin rights, you can do whatever you like. So changing the default passwords, even though it's not the same on every device, it's not a globally default password, it's a default password for that device, so that should be changed. Windows devices have default built-in administrator accounts. That comes disabled by default, but you still should ensure and double check that it is disabled and reset the password to a random password. Mac devices have the default account that you log on to that does have administrator rights as well. It will also its default root password, although that's not as important or as big as a risk as it is with Windows. Locking mechanisms for computers and mobile devices. So each device should be configured to have a password, PIN, or biometric to unlock it. So that's computers, that's laptops, mobile phones, tablets, any device that provides access to your organizational systems and organizational data should have some form of locking mechanism on it. And the best practices are that the device should automatically lock after a certain period of time. So if when you walk away from your computer, if you forget to lock it, it will automatically lock so that somebody can't jump on and start to use your computer and access the information. The rules around the length of password or PIN for this locking mechanism vary. From a Cyber Essentials point of view, it has to be a minimum of an 8-character complex password, although I can show you some statistics on how easy it is to crack such a password. So I would recommend 12 characters at the bare minimum for a password, and for a PIN, 6 digits. But if you're using biometric as well, that can make life a lot easier. So facial unlock, fingerprint unlock, which is also possible with Windows devices now, using something called Windows Hello, means that you don't have to remember these lengthy passwords all the time. You know, there's an easier way of getting into the device on a day-to-day basis, but it's protected by you as a person, essentially using a biometric signature such as a face or as a fingerprint. So one of the things that's often overlooked is autoplay. So if you remember that, if you're old enough to remember the days of CDs and DVDs, when you put one of these devices into a computer, well, if you're old enough to remember the days when things had a CD device built in, They don't tend to anymore. But when you put some media into the system, it would automatically play it. It would pop up and play whatever was on there. But the same also goes for running applications. If autoplay is enabled, it's a way of malware infecting devices. So a common technique that used to be used, possibly still is used by hackers, would be to drop a USB device in the car park. And that USB device would contain malware that, if auto run was enabled, it would automatically install onto the devices. Because curiosity, you drop a USB in the car park, somebody picks it up, and they're going to want to know what's on it. So they go plug it into their computer, and it was quite a simple way for an attacker to install some software in the environment. So by disabling autoplay on specifically Windows devices, but any other type of device, this will mean that if you do plug in some media that contains some dangerous software, it won't automatically execute that software. And again, this can be controlled either manually or through policy. If you've got your system's connected to an overarching environment that can control that policy. Removing admin rights. So this is probably one of the first things, the easiest ways to protect your environment. As I mentioned previously, when you first, if you set up a new Windows device or a new Mac device, you get admin rights on that device by default. When you have admin rights, essentially means you can do anything. So this gives a lot of, or presents a lot of risk for environments if users are using their day-to-day user accounts with admin rights. Because if they download something from the internet, if they open a malicious email, if they have admin rights on their computer, essentially that software, that malicious software, can do whatever it likes on that device. It can do something called maintaining persistence, where it can install services. It can modify the system so that whenever the computer restarts, the attacker always has access to that system. If you remove admin rights from the devices, then it really limits the surface area in terms of what that software or any malicious piece of software can do. So if you're going to do one thing with your business system, make sure that users aren't using admin on their day-to-day accounts. And that also goes for any other systems, such as cloud-based systems, whether you use Google Workspace or whether you use Microsoft 365. The accounts that are used for day-to-day access should not have admin rights, because again, if your day-to-day account has full admin rights on Microsoft 365, if an attacker gets access to that computer and you're logged on with that account, they can get into the admin consoles and essentially take down your business. And the same goes for any piece of software that you're using. If you have a user account that logs into it, have a day-to-day account that has as little rights as possible for you to be able to do your job, and then has separate admin account that you log into when you need to perform admin functions. So I mentioned previously about removing unneeded applications, because they basically provide, the more applications you have installed, the greater the surface areas for attack. One way that is sort of best practice is to have something called a gold build. So a gold build is essentially an image of an operating system, whether that's Windows, whether that's Mac, and it's pre-configured with everything you need as a business to run and nothing else. So it's essentially the basic operating system plus any applications that you require on top of that. Using a gold build means you have a known standard image that you can install onto every computer within your environment, and it's a known configuration, a known secure configuration. However, people are moving away from that now. It is still valid, It is still doable, but the more modern approach is to build systems on demand. So we use what we call a vanilla image. So that's basically the standard operating system image that's installed onto devices, and then you use a configuration utility such as Microsoft's Intune or System Center Configuration Manager or others to install the applications that that person needs. So the first time that a user logs on with a very a base operating system image, they connect to the business systems, and then that then configures all of the software that they need. And again, it's the same net result. You just have a system with essentially the only things that are required for that for the users to do what they need to do. So there are many benefits to doing this, and it also means that with the modern approach, the problem with the gold build is it was tied to particular hardware. So you had to buy all the same devices, you had to have all the same models of laptop or desktop computer. With the new approach, you can use any type of hardware because it doesn't really matter. Because when the operating system installs the vanilla version, it will set itself up for that hardware. So you can have a bit more of a blended approach in terms of the hardware that you use. Device encryption. So pretty self-explanatory. Encryption on the device basically scrambles all of the data on that device. So it goes from what's called plain text, i.e. text that you can read, into ciphertext. So it's text that is illegible unless you have the correct keys to access that. So it requires encryption and decryption keys to unlock the data on that device. And without those keys, you don't have access to the device. Windows now, out of the box, if you log on with a Microsoft account, so if it's a home device or a business device, if you're logging on with a Microsoft account, it will automatically encrypt that device with something called BitLocker. So that scrambles the data on the disk. So if anybody gets access to that system, if they can't log in, they can't access the data. Even if they remove the disk, they can't get access to that data, which is great. However, you need to make sure that you're managing the keys for that encryption, because if you don't have the keys, you don't have any data. An encrypted device without any decryption keys is a brick. You may as well use it as a doorstop because you can't actually access the data. So because Windows is now doing this by default, it's important that you understand where your decryption keys are, because if you need to get access to that data, you will need those. And secure boot. So secure boot, again, is something that's built into modern operating systems, and basically it secures the environment to make sure that the operating system can't be modified. In fact, if the operating system is modified, it won't boot. It uses cryptographic technologies to verify that the operating system on the device is installed in a secure way and nothing else has got in between that into that boot process. There's a piece of software known as rootkits, which can sit between the hardware level and the operating system level, and you would never know they were there. And that can give full access to a system. So the secure boot will protect against that. And I pretty much guarantee that, if you've got a device and it's running Windows 11, it will definitely be using secure boot because it is a requirement of Windows 11. Running older devices potentially won't have this feature enabled. As you're probably aware, Microsoft are stopping support for Windows 10 in October this year. And one of the reasons that they are pushing people down the Windows 11 route is because Windows 11 requires a lot of this additional security, such as secure boot. So yeah, it's something that's been turned on by default for quite a while for modern computers. You probably don't even know that it's there, but making sure that it is turned on is it's quite an important thing to do. So something else that you can do to secure the configuration of your systems is to use a restriction based upon location. So within a lot of software these days, cloud-based software specifically, you can lock it down to only allow access from specific either geographic locations or from specific IP addresses. So if potentially, your office. So this basically means that people or external to your offices wouldn't be able to access the cloud-based systems. Now that has obviously advantages and disadvantages. One of the benefits of the cloud is that it can be accessed from anywhere. However, if you're using a system that's got highly sensitive data, it's highly recommended to lock it down. So at least it can only be accessed from the UK, for example. We use a system to monitor our clients' Microsoft 365 environments, and the number of attacks that we see coming in from all over the world is scary. So from China, from Russia, from not just those places, from all over the world. So if you want to really sort of lock down a particular system, using a restriction based upon location is the best way to do it. Again, as I mentioned, if you're using a piece of software or cloud-based software that is very sensitive, locking it down to using it only allowing access from your office location, and then making sure that your users come through the office location using a VPN to access that software is the best way you can lock that down to a specific location and ensure that anybody outside of that location can't get access. Anti-malware, another part of secure configuration. We discussed this in one of the previous webinars. Can't remember if it was the last one or the one before that. I think it was the last one. So making sure you've got anti-malware software that's installed and that it's up to date, licensed, and that it's getting regular updates. Again, it's just a given now that this the anti-malware software should be installed on all devices. And then finally, an additional thing you can do with regards to secure configuration is something called application whitelisting. So what this does is basically says that you can only access business systems or business data using known trusted applications. So from a Cyber Essentials point of view, this is a common configuration methodology when using mobile devices. So as an example, there's lots of apps on the App Store that could potentially access your email systems, and they may come with sort of nice emojis and stuff like that people like and want to install. However, a lot of these are, potentially leaking data out of your environment. So by locking it down, but to say that we will only allow official Microsoft applications to access Microsoft environment, you limit the surface area by only allowing trusted applications. So that's one example of application whitelisting. There are others. You can do it on desktop devices and lock it down that way. But it is a good way of ensuring that only trusted applications are accessing your business data. So quite a bit of information to digest there. But let's focus in on the specifics of what Cyber Essentials says about secure configuration, because some of those things I've just discussed, they're best practice, they are good to do, but they're not necessarily required by Cyber Essentials. So these are the things that you would need to do for Cyber Essentials. So remove admin rights from all devices and only or all day-to-day accounts, let's say. So the day-to-day accounts you use for your work don't have admin rights, and use a dedicated admin account if you do need to do any admin functions. Remove unnecessary software and user accounts. Change default passwords on all devices. Disable auto run, enforce device locking across all devices, install anti-malware software and keep it up to date. Remote wipe and encryption is recommended, but it's not mandatory for Cyber Essentials. So I would recommend you have those capabilities to encrypt and remotely wipe devices should they become lost or stolen. However, it's not needed for Cyber Essentials. One important point to point out with regards to Cyber Essentials is BYOD. So BYOD stands for bring your own device. So that is using a personal device to access business data. So whether that's a laptop, a mobile phone, if it's not owned and managed by the business, it's BYOD. And these devices are in scope. So if you have employees that are accessing their email using their own personal mobile phone, that then becomes in scope for Cyber Essentials, and you have to do all the things listed here on those devices as well. Now, there are ways of doing it. There are technical ways of enforcing that, or you can also do it through policy and have a policy that says you don't access business data using personal devices, or you have a policy to say if you are going to access this business data, you need to let us check your device to make sure that it meets the requirements. The simplest way, although it is more costly, is to use a piece of software to control the access on that personal device. But this is one of the trickiest areas when it comes to Cyber Essentials, because it's just become the norm for people to access their emails using their personal devices, their work emails. So it does become a little bit tricky, but there are ways and means of making it a little bit easier. Okay. We'll do questions at the end rather than stopping part way through. So if you do have any questions, either put them in the Q&A and we'll deal with them at the end, or just speak up when we get to that point. Okay, so next we get on to firewalls. So yeah, what is a firewall? You're probably familiar with the concept, but just as a bit of a recap, it's a network security device that protects one area of a network from another area of a network. So typically, for most people, it's protecting the internal network from the internet, although it can be used for sort of segregating off different parts of your network internally. But for most small businesses, it's there to protect you from the internet, essentially. And there are lots of things that it can do in terms of protection, which we'll come on to in a bit. It provides a protective barrier, and it can also monitor the traffic that's coming and going between the two different networks. So in terms of different types of firewall, there are several. So we're just going to discuss some of the main ones that you're going to come across or may come across. So you have stateful firewalls and stateless firewalls. So a stateless firewall is the most basic firewall. Within a firewall, you have to basically open up, think of the Swiss cheese analogy earlier, you open up little holes in the firewall that allows traffic to pass through. In each different service, so whether that's email, whether that's internet, they use different what's called ports to allow traffic to pass through. So stateless firewalls don't understand the difference between the traffic leaving the network to the traffic coming back in. So, for example, if you go to a website, it knows how to allow the connection out, but it doesn't know anything about letting the connection back in. So you have to open a port on both sides. Stateful firewalls maintain the connection. So it understands that my computer going out from here to Teams, for example, it will automatically open a port to allow stuff back in. So it basically makes them simpler to configure. And pretty much every single firewall you will buy today, even the ones sent to you by your internet service provider, will be stateful firewalls. You don't really come across stateless unless you get in, sort of really geeky and building a Linux system with an IP tables firewall. And that's probably going to go over a lot of people's heads. Any firewall that you buy these days is at least going to be a stateful firewall. Knocking it up a notch to a bit more an application that's a bit more sophisticated, or firewall that's a bit more sophisticated, would be application layer firewalls. So not only does it understand the traffic is bound for the internet, and it's bound for a website, it also understands what application it's connecting to. What you're not potentially not aware of is when you talk to, let's say, SharePoint or Google or something like that, if you use Workspace, it's all going out over the same port, which is HTTPS. So you see in your browser HTTPS, it's all going the same way. So to a regular firewall, that just looks like HTTPS traffic. Application layer firewalls can decode the data within that traffic to understand what type of application it is. So you get a lot more granular controls. So you can say, I want to allow access, let's say, to SharePoint, but I don't want to allow access to something else. It's able to drill down, and it's able to give you an idea about all the different types of applications, cloud-based applications that might be being run or accessed from your network. So I'd say any kind of enterprise firewall will have application layer capabilities. So your home firewalls that you get from your sort of ISP, or the cheaper firewalls that you might buy yourself, probably won't have this capability. But when you move up a notch to more advanced firewalls and start paying a bit more money, they've probably got this built in. Then we've got what's called next generation firewalls. So next generation firewalls, I don't know why they're still called this, because it's been a term for about 20 years, but it's basically building in multiple different features within a firewall. So all the things that I talked about previously, the stateful firewall, application firewall, and a lot of other features such as malware scanning. So as you download files, it can be scanning them for malware. Sandboxing, a cool piece of technology that takes a file, detonates it in an area to see what it does, analyzes whether it's good or bad, and then if it's good, lets it go. If it's bad, it will block it. Web content filters, so you can control what type of applications and websites and so on are being accessed from your environment. So you can block, malicious things, dodgy things, gambling by using those filters. And it can also do something called DNS security as well. So there's lots of different things in here, and I'm not going to drill into this, but the next generation firewall, so things like Sonic Wall, Fortinet, Sophos firewalls, they're all what would be called next generation firewalls. And again, that's moving up the stack to spending a bit more money on a firewall and getting those additional protections. And it's certainly worth doing if you've got a business with several users and you want to be able to apply policy around what people are allowed to do with your environment when they're on the internet. Another type of firewall, endpoint firewalls. So built into every operating system is a firewall. So within Mac, you have firewall, Windows, Linux, and so on. These are really important for when, with the world that we live in, people can work from anywhere. So, if you're working from Starbucks, if you're working from home, if you're working from, wherever you are, an airport, the endpoint firewall is what protects your device. And these have the same the endpoint firewalls have the same capabilities of the stateful firewalls, and can provide a lot of sort of control around what can happen. But generally, on the endpoint firewalls, you want to be blocking all the traffic that comes in, because you don't want anybody accessing the computers remotely. And then taking it a notch further, so sort of beyond firewalls. So because of the world that we live in now, in terms of, lots of things are in the cloud, lots of dispersed systems, bring your own device, variety of, shadow IT, if you've ever heard of shadow IT. So this is where somebody goes off and says, I don't like this application that's been provided for my business. I'm going to use a different application, and it can lead to potential data leakage and so on. That's what's known as shadow IT. So there are lots of other additional security features that can be layered on through firewall-like appliances. So software-defined WAN. So this allows you to build a wide area network across the internet. So previously, if you wanted a wide area network to connect multiple branch offices, you either had to connect them all with VPN, which can be slow and troublesome, or you had to purchase dedicated MPLS or lease lines that are expensive. With software-defined WAN, you can do it in software, you can basically say, okay, these two devices here extend my network across the internet. So it's a simple and cost-effective way of expanding your business network across multiple locations. Cloud access security brokers. So these protect against shadow IT. So you can control what cloud services people are allowed to use. You can also control the features within those cloud services and so on, and lock those down. Zero trust is the sort of next big thing, really. It's all about locking things down so nothing is trusted and everything has to authenticate. So it doesn't matter what device you are or who you are, you're automatically considered as potentially hostile, and it will check your device to make sure it meets the requirements before allowing you in. And then SASE, or Secure Access Service Edge, and that combines all of those technologies together into a single solution to provide much more secure features around your environment. Okay, so again, a lot of information there, but let's drill into what Cyber Essentials says about firewalls. So you need to deploy firewalls for everything that's within scope. So this doesn't have to be, an all singing, all dancing next generation firewall. Any firewall will do. So when we talk about things in scope, this is all your devices. So all devices have to have a firewall installed and enabled, and your network locations. So your offices and so on have to have a firewall installed. It doesn't include home broadband. So where we have the problems with personal device use for accessing company data, if a user's working from home, Cyber Essentials doesn't extend to the home broadband firewall. So you don't have to worry about talking people through resetting their firewalls, resetting the passwords on their home firewalls and so on. You should block administration from the internet. So that basically means you shouldn't be able to connect over the internet and log into the admin page on the firewall. That's default. It will be turned off by default. However, I have come across some environments where that's being allowed, and yet absolutely shouldn't be. Change all the default passwords on your firewalls, as we've mentioned. Limit inbound connections. So if you run an application in your environment that needs access across the internet to get to it, so let's say, I don't know, you run an in-house web application, that's fine. But you need to sort of make sure that those rules for allowing inbound connections are reviewed regularly, and Cyber Essentials wants to know, how often you do that. Do you have a policy for, what is your policy for doing that? But if possible, block all inbound connections. And if you host externally accessible services, they must be secured. So this is, again, if you're running an internal service or server or website or something like that, that provides business functionality that you either provide to your employees or to your customers, then you need to make sure that that's secured using, multi-factor authentication and strong passwords. And just a note on RDP. So RDP is remote desktop protocol. So during COVID, the way that a lot of businesses dealt with providing access to people to work from home was to set up a remote desktop server in their office and allow people to connect in from that. There are secure ways of setting this up, but a lot of them were just sort of fast and dirty and set up really quickly, and some of those are still active. So essentially, speak to your IT people and see whether or not you're still allowing access to direct RDP from the internet. If you are, that's a happy hunting ground for hackers. They will, they scour the internet for these types of services because they're quite easy to hack if you haven't secured them correctly. Okay, so that sort of draws us to the end. So yeah, in conclusion, secure configuration and firewalls are both important when it comes to Cyber Essentials, and you need to make sure that you're doing things correctly, because it's going to limit your surface area for attack and reduce your overall risk. And do we have any questions? I appreciate that there was quite a lot of information there. Any questions from anyone?